Well, on behalf of the Computer History Museum, I'd like to welcome Bob Garrow Sr. for his oral history interview. My name is Uday Kapoor. I'm a volunteer in the Computer History Museum's Oral Histories program, and along with me is Dane Elliot, my colleague. So welcome, Bob.
Thank you. Glad to be here.
Bob Garrow Sr. is a senior executive in the Silicon Valley with an illustrious history. He was born in 1942 in Antioch, California, and grew up in Stockton. Graduated with a BSEE from UC Berkeley in 1965. He worked for Lockheed, Intel, and before co-founding Convergent Technologies. Then he joined Sun Microsystems in 1986 as VP General Manager of the Workstation Division. He left Sun after 4 years of extreme growth and left as VP of the worldwide manufacturing. And he tried retirement, which he didn't like. He then co-founded Liquid Computing in Ottawa in 2003. After a long struggle, the company, as Bob puts it, snatched defeat out of the jaws of victory. He has been a consultant ever since and is still active in the industry. With that, welcome, Bob.
Thank you.
So we'll get started from your early life. You were born in Antioch, as I said earlier, grew up in Stockton, and your ancestry, interestingly, Italian grandparents on one side and Scot and Irish on the other. So that must be an interesting mix. Can you tell us a little bit about your background?
Well, that was an interesting mix. I grew up at a time in the 50s, which is represented fairly nicely by the movie American Graffiti. Stockton is a town in the Central Valley here in California. I think the film was made in Modesto, which is 20, 30 miles south of Stockton, and life was simple, but life was very pleasant in those days. I was a part of the first generation of my respective families to go to college and get a degree. My Italian grandmother and grandfather had a small farm outside of Stockton. The family used to refer to it as a ranch, but it was a small farm. Hardworking people, big family, and I cherish my childhood memories from those days. On my father's side, my grandmother was Irish, and my grandfather was Scotch. They had a small local grocery store, little tiny grocery store that they serviced the community with. I didn't know my grandfather well at all. He passed away when I was quite young, but I remember my kindly, hardworking Irish grandmother. And somehow I think I inherited a lot of those hardworking genes, because I've always enjoyed, working hard at what I do. But in my high school years, I was a little lackadaisical when it came to studies. I enjoyed sports. I enjoyed playing basketball most of all, even though I was the shortest guy in my class for many years. I enjoyed football and baseball. But I didn't really take my studies that seriously. That I just couldn't help but notice that math was easy for me. I enjoyed my math classes. So somewhere along the line, probably my junior year, I discovered physics. I had my first physics class, and I really liked it. I loved it. So I started taking greater interest in my math and my physics classes. And in my senior year, I finally decided I wanted to go to Cal, but I clearly wasn't going to be able to present the grades I needed because of my lackadaisical years in my early part of my high school career. And so I applied and got into the city college there, which happens to be known as Delta College in Stockton. And I spent 2 years there and was inspired by two teachers. One was Mr. Clark, my physics teacher, who he prided himself on teaching his physics class as if it were being taught at Cal. And it was a tough class. He hadn't given an A out ever in his entire tenure at Delta College, and very few B's, but I later benefited from that rigor. My math teacher, Mr. Simley, was a second inspiration for me. He was the kind of teacher that just loved his subject, and he just made it fun to come to class, and I remember just really loving calculus and differential equations, partial differential equations, and talk about being a geek. I love to do power series solutions, and if you've ever done those, you go through reams of paper, statement after statement after statement, and I was always amazed at the end of that process when the solution actually dropped out. I really thought I had my first love figured out, which was math, and so.
Bob, what was the high school you graduated from?
Oh, Amos Alonzo Stagg High School. And Amos Alonzo Stagg is known as the father of football. And by the time I was in school at Stagg, he lived in Stockton actually, and he was a kindly little old man with white hair, and his wife was still with him, and he was kind of part of the pride of Stockton. And people really liked to have him around.
So after the junior college, you were looking to go to university, and you selected UC. I guess you studied hard and you got into UCLA.
Well, yeah, I had to take the upper division entrance exam because I wanted to enter UC as a junior, and it was I remember it was a 2-day rigorous, about 8 total hours of testing, and I did well, but what surprised me is that it wasn't my math scores that were the highest; it was my physics scores. So I have to thank Mr. Clark for giving me that skill. And I did get in. I did pass the test, and I was accepted at Berkeley. But at that time in my life, I wanted to get a little bit further away from home, and so I requested a transfer to UCLA, and I spent a year at UCLA, and it was a lot of fun. I have to say that, but it was hard to keep up with your studies, but because it was so much fun. But actually, though, I discovered that the curriculum at UCLA was a little too general for my interests. They required a lot of civil engineering courses, et cetera. And I was still very interested in math, and so I returned to Berkeley after that year at UCLA.
So understand you also got married.
Yes, I did. I married my high school sweetheart, Roberta. But the day before classes started in my first year at Berkeley, we got married, and I went to work, completing my bachelor's degree at Berkeley. She helped out all the way along. She's one of my biggest inspirations because she has always given me the confidence to move to the next step, and I thank her for that.
Does she also have a subject that she studied in?
Yeah, she was an English major and a communications major, And
And I think you had a son very soon after that. So.
yes, yeah, it was by today's standards, we were fairly young, I have to admit. But I had in my senior year at Berkeley, my son was born, but the circumstances were that I had to take my finals. And Roberta went back to Stockton to be with her mother, and I was in Berkeley taking my finals. And the day I completed my finals, I drove to Stockton. The next morning, my son Bob Jr. was born, and that was the first semester of my senior year at Berkeley, and I graduated, 6 months after that.
So after your graduation, I understand you elected microwaves as your subject.
During my upper division, I elected microwave. I enjoyed the math. I thought that would be pretty math intensive, so that's what I did. But in my senior year, I decided that I didn't want to continue because I had this senior lab at Corey Hall, and I spent hours and hours bolting waveguides together, and I decided then that I wanted to finish my specialty and complete that, but I decided that I wanted to go into circuit design, and that's why I continued my studies at the University of Santa Clara in part. I had a little bit of circuit design, but I was specializing in antennas and waveguides and things of that nature.
So understand that basis of microwave theory and so on helped you later in your designs and concepts of designs.
Yeah, it came back later at Intel, but I think the theoretical grounding that my schooling at Berkeley gave me was kind of stood the test of time and carried me through many different, technical, disciplines that I had to deal with.
So you had a couple of job offers, one from Hughes and one from Lockheed?
Yes. Yeah. Having my son when I did, I was highly motivated to get a full-time job. I had previously worked for 5 years, actually, summers, actually, with what was called the Division of Highways, is now Caltrans, and had some of the best summers and summer jobs ever, but I needed a full-time job. So yeah, I had one offer from Hughes, one offer from Lockheed, and I happened to do my interview at Lockheed on a beautiful, gorgeous, sunny day in Sunnyvale, and I knew Roberta would love it down here, and we both did. We've been here ever since, and so I picked Lockheed and went to work.
So what was your early job like at Lockheed?
Well, I was a circuit designer in a group that was responsible for the flight controls in the Polaris and Poseidon missile, and I learned a great deal about margin and designing with great margin, because those circuits had to do their job, which is an amazing job that they had to do, despite serious degradation from atomic weapon, radiation, things of that nature. So
Extreme heat.
yeah, and he designed with alphas and betas that were like almost nothing, but your circuits had to continue to work. And I think that work, made me a very conservative designer, and I think that helped me down the road. And I remember that coming from my background, I was just going to be very excited to be doing circuit design. And I remember being so happy my first, days at Lockheed, sitting in front of my desk with a pencil and paper, it was vellum, and drawing out circuits to do my job.
Now these were, the devices you were using weren't integrated circuits at that time. They were individual transistors and...
It was actually a mix of both. The technology back then was being used was DTL. But I had to do a lot of research and experimentation with actual devices, to study the effects of radiation on the circuitry inside of the chips. These were little tiny flat packs that were actually welded in a three-dimensional circuit.
Yeah, ceramic flat packs, welded designs.
Yeah,
right.
yeah.
What do you think the date was that you were, what day did you start at Lockheed?
Oh God, I can't. It had to be 1965. That's when I graduated, but I don't.
Not a specific day.
June, July, something. I don't know the actual
Okay.
date. Goes too far back, Dane.
Yeah, my background was much like that, except I started with RTL, not DTL.
No, I have an RTL story too.
So you also participated in the underground atomic test in Nevada.
Yeah, that was really something. That was quite something. You probably know those missiles they were intercontinental missiles and tens of thousands of parts. They had to, fly at those great distances and zero in on targets with amazing accuracy. So the reliability that whole system had to maintain to do that was just incredible. So yeah, we did live testing, underground testing, and I was assigned to lead one of the big tests outside of Las Vegas, and so I commuted in a sense. I spent 7 weeks out in the Nevada test site, which used to be known as Jackass Flats, and that was quite an experience. And it was I think it was probably one of the last underground tests series that was ever done.
So that was in the 65, 66 time frame as well?
Probably 66. I was at Lockheed about 3 years.
Is that now known as Alamogordo? Or is that a different test site down
I
there?
don't know. I don't know. It's the it has a different name when you hear about it on the news. There's a different name, area. I can't remember what it is.
So looks like you were also continuing to educate yourself. You were taking early bird classes at Santa Clara University.
Yeah, I wanted to move in. I needed more digital design background and logic design, and I did because I hadn't taken that many courses at Berkeley. So while I was at Lockheed, I took advantage of the early bird program at University of Santa Clara, which was fantastic. My oldest son later, many years later, did the same thing. So I think it's still there.
Yeah, I took classes there too. In fact, I was asked to teach a class there once.
Yeah.
So then you moved from Lockheed after, like you said, 3 years to a company that designed instruments for lab testing.
Yes.
And what was the name of that company?
It was called El Dorado.
El
It was up
Dorado.
in Concord. I felt I needed to move out of aerospace. I thought I was going to get typecast, if you will, too narrowly. After a while, I was beginning to figure things out, and so I wanted to do some commercial. I wanted to do some commercial products. And still a circuit designer, not a not a computer designer by any means, but so I took advantage of this to help me move in that direction.
And you worked on understand a 10 nanosecond time interval meter.
Yeah.
And there was
Yeah.
an interesting story about the flea.
Oh yeah. That's another. I refer to as a career change motivation. And to your point earlier, Dane, about the RTL, this 10 nanosecond time interval meter was it was a rough prototype, and my task was to turn it into something the little company could produce. So I wasn't going to invent the thing, but I inherited. It had a tunnel diode discriminator to catch the edge of the signal. It had a ECL stage at the front end. Then it went through TTL for a stage. You know, the frequencies were coming from 100 megahertz down. You know, then it went through DTL, and then it ended up at RTL because, you know, if you remember, the transistor, it doesn't have it's just exposed to the outside world, and you can put a load on it or what. And I had to drive these ancient, they weren't ancient at the time, they were contemporary, but those little Nixie tubes. The instrument had about 9 or 10 Nixie tubes in front, so went from ECL all the way through RTL. So I had to design a power supply for it, and I had to get it working. It wasn't generating it wasn't generating a stable 10 nanosecond light. That 10 nanosecond light had to be stable. It couldn't be moving around because it couldn't sell the things. So I worked on that tirelessly, hour after hour, and I remember working in the lab many long hours, many of them at night. And so you've experienced, if you've done circuit design, you know that all kinds of things can happen and things go up in smoke from time to time. Well, things were pretty stable. I was about midnight one night, and I'd been doing this work for weeks basically, and I was looking into this little box. It was about 8 inches by 10 inches, and I'm not touching it. I don't have any probes in it. I'm just looking at it, and I'm tired, and all of a sudden I hear this little tiny pop, and a little whiff of smoke comes up out of the open box, and I'm thinking, what the hell went wrong this time? And circuit designers, they know that solder balls cause this, and if they change the circuit, it might smoke. But I wasn't doing anything. I hadn't changed anything, and I leaned over and I looked into the printed wiring board was it was blue. I remember it was blue, and the traces were kind of a silver color, and I saw a little black spot, and I recognized that it was between the 110 volt Nixie trace and some low voltage logic, and I said, "Oh, God, what caused that?" And I looked closer, and I swear to God, this is true. It was a flea. A flea had landed and straddled those two voltages and got electrocuted.
So there was a bug in your design.
There's a bug in mine, exactly. And I remember thinking, right on the spot, I said, I've got to move into digital logic design now. And I did my job. I finished got the instrument working, but it took me to the next stage it took me to the first real digital stage of my career, because the company shortly thereafter decided it wanted to get into the computer business. And they wanted to do that by designing and manufacturing an intelligent terminal. Now, back then, this is 1970, something like that. And they hired an architect from Los Angeles by the name of Dick Pasternak. And he had been, like Dave House. Back then there were these microprogram mini computers on the West Coast. DEC was the big powerhouse in minis. They were going strong, but all of their instruction sets were proprietary. But there's a couple of companies, maybe more than two companies in the LA area that built basically a mini computer, system, but allowed customers to program the instruction set using non-volatile memory. But it was this is way back. The random access memory was literally cores sewn together by.
So I assume the code was in a bipolar PROM or something like that.
No.
Not even that.
This was the one product I can remember for sure is the Micro Data 1600. And actually, I have to thank Dave House for helping me remember that designation. It was the Micro Data 1600. Again, it's not like 8 by 10 card, 8 by 11 cards, and the core memories were really core. They were boards with very tiny cores, hand stitched together. The read-write lines were literally hand stitched together. The read-only memory was a board on which you soldered diodes vertically, and the presence of a diode was a 1, and the absence of a diode was a 0. And I think the memory capacity for the board was like 4 kilobytes. And I don't remember what the read-only memory capacity was, but you can imagine it wasn't very big, with individual diodes stood up vertically.
Yeah, my first computer was 4K.
Yeah. So, to give you a picture of an intelligent terminal back then, the keyboard was an IBM Selectric. The keyboard technology wasn't, that common back then. You couldn't just buy it.
Well, Selectric was a big step up from the old clunking KSRs that we used to have. So
that was the Microdata 1600 was the computer. The removable storage happened to be these Sykes Datatronic reel-to-reel tape drives, and they were designed pretty well. They weren't like automobile cassettes. They were designed to be rugged, and I was given the job of designing a controller for the tape system, and that was my. I was happy to be away from the fleas, though, because I didn't have to worry about that anymore.
So I guess one thing I'm not quite clear on. So you could customize your instruction set in these things and put them in the diode. So that was basically
that's your firmware,
the microcode, the firmware as we think of it today. Was that a manual task? Was there any assembler? Were there any software tools to develop that?
No. They came along within a year or two, and because I needed. Oh yeah, I should tell you about how I discovered microprocessors at this point. This was Dick Pasternak had taught me how to use a state machine for doing control, and that was the basis for my tape deck controller. And so I was becoming, more aware of computing, how things were done. And I'm sitting there I was reading my EDN magazine, and I picked it up, and I looked, and on the front cover was a picture of a wafer with a whole bunch of circuits on it, and the headline was something like 4-phase develops microcomputer. The term microprocessor, I don't think was used back then, but and so I remember my thought then too. I said, my God, this tape controller took 2 boards, one board for all the logic, one board for the tape controls, and I said, my God, the work I've been doing the last year for that one board to control it is engineers are going to be doing that work in a totally different way very soon because of this microprocessor, and I've got to get involved in that.
Now, to be clear, 4-phase was a multi-chip design, if my memory serves me correctly, and they weren't selling chips. They were selling
That's right.
the computers that they built those chips into.
They were doing a storage system, and I discovered that later. I discovered that those parts were not going to be offered, to the merchant market. They were for their
But it was pretty obvious that somebody would.
Yeah, but I realized I had to do at least one thing. I had to get back into Santa Clara Valley. So Nick Nichols, PhD from PhD from Stanford, hired me to work on a Microdata 3200, I think it was, because he too was doing an intelligent terminal, and he had some ideas about how to extend the instruction set for word processing. I can't remember exactly what he was targeting, but he needed an engineer that knew.
So this was a small company.
Pardon me?
Nick Nichols had a small company.
Yeah. And so I came back to work for him, and while I was there, I wasn't there very long. I'll tell you why. It's kind of a funny story. While I was there, this Intel salesman, I believe it was Jess Unruh, would call on me to show me Intel parts and things of that nature, and it was through him that I discovered Intel, the 4004, and I said, that's it, I've got to get to Intel. That was the next step, and we didn't have. I was just thinking about it. We didn't have Google or the internet. We things weren't that readily available to us in terms of what was going on in the world. But I had a job to do for Nick. And Nick was I remember he's a really nice guy, a great boss, and very smart guy. So I'm working on this. He wanted me to extend the instruction set from a hardware point of view, not just firmware, of this Microdata 3200. And by then, these ROM simulators were available. So they were pizza-sized boxes, maybe double pizza-sized box, and I could simulate or he could simulate the firmware using the ROM simulator. You'd have to, solder diodes in and out. So that was a factor, and so I went to work adding I forgot exactly what instructions I added, but I needed to add some instructions to the hardware itself. But he had hired a firmware designer, a young lady, to do his firmware for his application, whatever it was. And so I was busy doing my hardware design work, and he was having her do the firmware, and I'm moving along, and I finally get my part of it done, and I want to test the box. And so I start testing, and the first thing I think of is, well, let's see how a no-op works, right? That's pretty simple. And so I'm running the no-op, I get it working, and with my scopes and whatever, and think, wait a second, this is kind of slow. and it turned out the no-op took 17 microseconds.
So the whole project was a no-op at that point.
Well, not yet, but it became one. And but as a systems engineer, I was testing other things, and I also realized that the system was consuming a kilowatt of power. And so I didn't want to be the bearer of bad news because Nick was a really nice guy, but I really had to tell him that his no-op was running 17 microseconds and his system was consuming a kilowatt of power. And that was the end of the project. He went on to test it himself and test more of the firmware, and it was he was forced to cancel the project, which freed me up to leave, and so that led me to Intel.
You don't recall the name of the company that Nick had at the time?
It was Sylvania. It was a small company that had been purchased by Sylvania. It's not just Sylvania. I forgot the full name of Sylvania back then. This had to be 1972. How
about the name of the firmware designer?
No, I can't remember.
No.
No, man.
So then you went to
way too
Intel.
hard.
So tell us about how you got into Intel.
Oh yeah. So so I forgot how I got my interview, but I was interviewed by this. It turned out to be this dinky little group in marketing under Mike Markle, I believe, about 10 or 12 people. Dane, I don't know if you were there before me or not.
Well, I was confused about that too. I started in April of '72.
Well, you were there a few months before me.
So I was there a couple of months before you, I guess.
I joined in June of '72.
Yeah, the only thing I can mark it by is that my son's 3rd birthday was celebrated up here instead of in L.A.
Okay, yeah, and Phil Ty was the leader of this group, very peppy. It turns out he was the Singapore national badminton champion, but he was a peppy guy. I liked him, but he told me that Bob Noyce wanted to hire a systems engineer to follow up on, at least one of the many RFQs for custom jobs using the 4004 that were coming into Intel, and so that he could maybe understand what the microprocessor might mean in the future, and so Phil needed to hire a systems engineer. So I actually interviewed with Bob, and that was one of the highlights of my career. Is not only just interviewing, but getting to know him. He's quite a guy, and so I got the job. And so I started looking through these various RFQs that were coming in, and I decided to take one on from a Texas company called Film Fast. Film Fast. and what they wanted was a controller that would go into an existing housing that they had with a keyboard and a display, that would run 16 pumps, gas pumps, amongst other things, go online through an RS-232 interface through an AT&T CBT access arrangement, upload data, download data, and also run a game that allowed customers to win credits if they could guess how much gas a fill-up would be, and also had to have a secure part of memory that was uploaded every shift, because there were shenanigans going on between the shifts at the gas station that the company had to protect against. I don't know what the shenanigans were, but all these crazy requirements. It had to be very compact. I think the board sizes had to be maybe 3 inches by 6. I could fit 2 of them into the housing, and I had to sell them for $250, both, fully tested. And so it was a perfect application for the 4004. And so that was my choice. I remember DRAM overhead was overkill. too expensive. Static memory would have been too power consumptive and too expensive. And there was maybe you can remember for me, there was a serial memory in the 4004 family.
Oh yeah, the 4002.
The 4002. So one board became the controller with mainly the 4004. The second board became a serial memory with the 4002, I guess. And I made them work, and it was amazing. It just astonished me that all that functionality at that low cost and that compact space was handled by these two boards, and the company sold them for years. Intel sold them to this Texas company, Film Fast, for years. So they worked, and I guess the customer was happy.
Do I remember correctly that you ended up putting 4001 ROMs in that too?
Probably. That certainly wasn't a 1702 PROM.
No, but I assume you had a 1702 to develop with.
Oh, sure.
Okay. But yeah, there was a 4004 with the processor. 4001 was the ROM memory with a few I/O pins on it. 4003 was your 4002 was the serial 4003. Then there was one more device whose number escapes me. Must have been the 3, and that was an I/O expander.
I was going to ask you about that. I need an RS-232 interface. Did the family have that on chip?
It did not.
Oh, okay. That was a UART we did later, right?
We did an 8251. Matt Meow did that many years later, but no.
So maybe some of my circuit design experience helped me get the RS-232 done. I'm not
sure it did, because nobody was doing that in chips at the time.
But I never heard anything about what that project taught Bob Noyce. I never did. I went on to work on the development systems.
Now, prior to that, in the write-up here, you mentioned some of the early stuff that you worked on at Intel before you actually created that, including, or worked with, I don't know, there was a SIM 401.
Oh, yeah.
Okay, I don't know who built that. Was that a Ted Hoff design?
Okay, I don't remember the product code, but when I got there, Ted Hoff had developed a 1702 programmer.
That was an MP703.
No, I don't think so, because
really,
the MP703 was our group's little. Let me tell you what I remember, and you can maybe fill in the gaps. Ted's product sold for about $5,000. It was a box, pretty big box, and Phil Ty, when I got there, was selling two alternatives to it. One was a bag of parts, which included a raw printed circuit board, a paper tape reader, and customers would buy them very cheaply, solder all those parts onto the board, get it working, and they could program 1702s that you would punch the paper tape using a teletype, run it through the paper tape reader. I think that might have been called the MP04, MP704, or something like that.
Okay, there were a number of them.
Then there was a box.
Right.
There was a higher end version.
That was Ted's baby.
No.
Oh no.
No, Phil took basically that board design and put it in an aluminum housing and finished it for the customer, so the customer didn't have to do any of the soldering. So there was like the very beginning of Phil's work was the bag of parts with the PWA. But then right behind that, but by the time I was there, he had this other fully assembled box that was tested that they were selling. But both were much cheaper than Ted's $5,000 box.
Right. Now, I had one of the original kits.
No, yeah. What was it called?
Okay, and I can't remember, but I do remember after I got there, we had the aluminum box with the board mounted on top,
Yeah, that's the one.
and that was had a 4004 running it
Yeah.
with a reader, and there was there was a board that plugged in. I thought was an MP703, but I can check because I know somebody who has it.
Could be.
Okay. And that was used, that was the programmer.
Yeah.
So you could write code, get it programmed into a 1702,
Yeah.
take the 1702 and plug it back into the board,
Yeah.
and then execute the code to see whether what you wrote worked.
Right.
Okay. So it was a pretty confused situation back in that day. It was very difficult. And
But
then-
weren't you responsible for writing the application notes that
I wrote
described how to use all that stuff?
I wrote a bunch of that stuff.
I thought so,
and not on the original stuff, because I wasn't
Yeah,
there when
yeah.
the board,
Oh, okay,
the kit of parts came out. I bought one. But later on, yeah. And that was one of my impetus to come to Intel, because you had your Jess Unruh. I had my Dave Neubauer, who was his equivalent down in Southern California. And Dave was trying to convince me that they had this part coming out called a 4004, and I could stop designing computers.
Yeah.
But I asked him all these questions about where's my development tools, where's my software, where's this, where's the documentation, and all this stuff. And that led me to come up to Intel a year later.
Yeah.
And that's another story, not your story.
So then you went on to development systems, I understand.
Yeah.
So tell us about that.
Okay, so let's see. The 8008 was in development. I think Federico Fagin was leading that effort.
No, actually Feeney.
Oh, Hal
was
Feeney,
the
that's right,
design
Hal
manager.
Feeney. So I finished my Film Fast project, and there was a development system for the 4004 that was beyond what Dane just talked about, called the Intellect 4, and a similar system for the eventual 8008 was being developed, called the Intellect 8, and I wasn't involved in either of those, except I gave it the name. I came up with the name Intellect, and back then, the Intel used a drop D in their logo, and I remember taking a couple of my business cards out and cutting out the letters and taping with tape, creating the logos for the Intellect 4 and Intellect 8 with the drop D, and the marketing guy there I think it was Jim Lally. He liked it. He said, "That's I like that name," and I liked the logo. So my only contribution to those first development systems was the logo and the name. But then Phil was replaced by Hank Smith from New York. Came in to lead the group. It was still a marketing group, but it was getting, and I don't think it was much bigger, maybe, but it was still in marketing, I think. Mike Markla left, and somebody else took over marketing. It might have been Ed Gelbach, but I can't remember. The first, I consider him the first visionary leader for the group, Bill Davidow, was hired to lead the group, and the timing for all this is a little fuzzy. I'm not sure what years these were. I was at Intel 7.5 years, but don't know when this was all happening. But the 8080, development followed the 8008, and the group wanted a more robust development system for the 8080. And Bill had this, I think it was Bill's idea, because Bill came from a company,
Oh, he came from HP.
came from HP, but I think there was a private company that he was
In
part of.
between?
In
Might have
between that made ROM simulators. I can't remember the name, but I kind of attribute the notion of the ICE emulator, the emulator of the 8080, to Bill. I'm guessing it was his idea.
Well, let me back you up a little bit. Time-wise, I think Phil Tye actually reported to Hank Smith for a while.
Oh, okay, okay.
Okay, and then I have never figured out whatever happened to him after that, but he was
No,
just
I
gone.
don't know either.
And in about 74 or 5, just about when the 88 was being launched, Hank Smith decided he had to move to the East Coast again.
Yeah,
And he and his wife did move back there. And David Howe came in about that time and replaced him.
yeah.
And so he had all the systems, all the chips, everything. It was
Yeah.
now a much more official organization, I think.
I think you're right. Probably no longer in marketing, maybe its own.
Yeah, because
Organizational
we used to
entity,
be
I'm not
called,
sure.
when I first joined, it was called MPO, Microprocessor Operation.
Yeah.
Just like we had Memory Systems Operation. They weren't separate divisions or anything at all.
But what I'm remembering is that somebody, I believe it was Bill, conceived of this notion of doing an emulator for the 8080 itself, and that emulator needed a system to run in, and I was given the job of designing that system, and with my mini computer background, quasi mini computer background, I thought in those terms. I thought in terms of backplane slots into which you can easily load a board, take it out, a bus, control buses, data and address buses. Hap Walker, our colleague, was given the task of designing the emulator. It was called ICE, in-circuit emulator, and so I kind of wanted a general purpose system into which the emulator would go, so that we could reuse it in different applications, different industries, and so we had to design kind of a general purpose computer. So Fred Curry, an architect from Hewlett-Packard, who may have been a consultant at the time, was hired to help do a bus design. The first engineer I ever hired at Intel, Rich Boberg, really great engineer, became a part of the team that defined this bus, and I was a part of this team.
So this is when the multi-bus.
This became the multi-bus, and that became the general purpose bus that the 8080 development system, had, and I think Fred provided the architecture, and Rich provided the logic, and my microwave training finally came into bearing on this project, because I focused on the guard bands within the bus, and my idea was I wanted the bus to be very compliant. I wanted less experienced engineers to not have trouble with it, to be able to plug in multi-bus compatible boards and have an easy time of it, and get things done
So I
rapidly.
understand Bill asked you to represent you in the IEEE.
Yeah, I was. Bill told me that Gordon wanted me to represent Intel on the IEEE standards bus for multi-bus. But just to finish, Jim Lally didn't. I wanted this thing to be called the Intellect 80, but Jim had lost interest in that name, and he named it the MDS 800.
Yes, he did.
And so that's fine, but I was going to say my microwave training finally came into use for me, because I worked hard to make sure that that there was a generous guard band in the time domain for all the specs on the bus, so that race conditions would be hard to develop. And I made sure that I remember using a time domain reflectrometer to make sure that the bus was terminated with perfect impedance, and I just wanted it to be really easy to use, and also my conservative design background, I want it to be reliable, and I'm kind of proud of that box, because it was kind of the highest volume development system box sold, and it was reliable all over the world, and people got good grades.
Well,
So
it was unique, and I have a couple of questions about that. All of the mini computers out there at the time had one big motherboard.
Yes. Well,
Okay,
I don't.
except DEC, who had
Yeah.
all these cards that they started out with, and then when they got to the point of building bigger machines, they built single motherboards in theirs,
Yeah.
and then they had a few plug-in cards. So the fact that you put a backplane motherboard in this thing, and then even the processor was plugged
Yeah.
into the thing,
Yeah.
was completely unique, I think, in the industry at that time. What I'm curious about is there was a board that I don't know where it fits time-wise, called an SDK-80.
Oh man.
And the SDK-80 had the form factor of the boards that you plugged onto that backplane, but it didn't have the bus to do that.
Oh, I know what that was.
It was a kit.
Oh,
SDK-80 was a kit, and it was only sold through distribution.
okay. I think I know what that was. Came from Bill Davidow.
Is that where it came from?
Well, we had this form factor. The multi-bus form factor was worked out, and we did all kinds of boards for our customers. But at one point, Bill felt that he had to put a price point out in the marketplace that was really low. What he wanted to do is protect Intel from, Motorola coming in and underselling them. I don't know what the background was for that, but he came to me and he says, I need an SBC card that I can sell for $250. I'm making that up, but it was a really low price, and it was like, I can't do that, Bill. These cards were, about 8 by 11 across, something like that.
This is the single board computer.
Yeah, these cards eventually became the single board computer format, but back in the time frame, oh no, you're right. This was a single board computer. I'm getting to it. So I couldn't figure out how to do it for $250, except if I lopped off that one section of the board that was for I/O, and that's what I did. I made this, and the MDS 800. The multi-bus cards were, say, this big. This card was about this big. And it wouldn't have worked for anybody, because you couldn't control anything with it really, unless you came right off the board. But Bill got his price point, and he was happy as can be, because
what had an 8080 on it?
No, well, it couldn't have had an 8080. It had to have something really cheap.
8008 or 4000?
8008 or 4004.
Okay.
It was a 4004. I'm pretty sure.
Okay.
So cheap.
Yeah. Well, no, the board I'm specifically talking about was an 8080 based board.
Oh, no.
And it was full form factor.
Oh, okay.
But Ken McKenzie and I'm going to forget the other name, developed this thing, and I've been trying to chase down for a long time.
SDK 80. Yeah. Okay.
System Design Kit 80. There was a System Design Kit 85. There was a System Design Kit 86 later on, but the original one, had the form factor of your boards, but it didn't have the multi-bus interface on it.
They didn't have the multi-bus interface.
No, it did not have the multi-bus interface, and it had a little area on it that you could put your own circuitry on it.
Oh, okay.
Okay.
Oh.
So it sounds to me like that must have happened after you came
Yeah.
up with that form factor.
Yeah, sounds like
Okay.
it. I think the name of the card that I was describing was the SBC04,
Okay.
but it was really just a marketing ploy.
Interesting.
That was its main
that's,
purpose.
That's what Bill thought about all
Yeah.
the time. Still does, by the way.
So you also ran into Andy Bechtolsheim at the.
Oh yeah. I would go to
Stuff.
these. Thank you, Uday. Appreciate that. I would go to these IEEE meetings for the multibus, and I couldn't help but notice this very, very young, blonde, near towhead, young German gentleman, very active in the meeting, very keenly interested in everything that was going on. It was Andy Bechtolsheim, and nothing, I didn't strike up a relationship with him or anything like that. It's just, he stood out, and I remember him being intensely interested in multibus. I found out a little bit later why he was so interested, but I did my job. And the multibus became a international standard, and it had a good run.
So relative to that also, Intel got into the single board computer business at some
Yes.
point in time.
Yeah.
Same form factor. Same bus.
Yes.
Right. Okay. And Rich.
I led that group. I remember I led not only engineering. I started a planning process that brought marketing and manufacturing together to.
This was in Oregon, though, right?
No, this was before Oregon.
Oh, before Oregon.
No, it started in California. Yeah, that was the group. That was another career
There was a
adjustment that I we'll talk about in a bit. So.
But this was, okay, so if it was in California, that was after David Howard started Development Systems as a division.
Probably.
Okay.
Yeah. Somebody got the idea, probably Bill. I think it was probably Bill. Let's take these multi-bus boards and let's configure them, or take the form factor and create this thing called a single board computer. We've got everything we need. We can get it all on one board, and let's start a family of computers that way. And one of the important things I remember about that is that I was told that Bob Noyce was loath to compete with his competitors. Just any talk of a computer system was, not going to go over well.
Still a chip company.
Yeah, because he was right about that. You don't. So I remember Bill probably told me that I had to get this single board computer line approved by the executive staff, and Bill warned me about the attitude, and I might run into some headwinds when I do that. And I remember tailoring my pitch such that it characterized the single board computers as merely components. They're merely components of a system. They're not a system. And it won the day. It was, the SBC line was approved, and the group started cranking out various family members, and then Andy Grove decided that it was a nifty little group. It was about 35 of us, plus some marketing people that were part of this planning process. It was a nifty little group to pick up and move to Portland, or move to Hillsboro in Oregon. And it didn't sit too well with me. Being a native Californian and just loving this area, I couldn't move. The thought of living in soggy Portland was not good. But the funny thing is, because I was part of these planning committees, I had to go up to Oregon, probably once every 6 weeks or so. So I traveled up there for several years, and the weather was always absolutely beautiful, absolutely, except for one ice storm that I got caught in. That was horrendous, but the weather was gorgeous up there. And I worked hard to get my team to decide to move up. About 65% of them, I remember, moved to Hillsboro, and they loved it there. Most of them, except for Jim Lally.
Yeah, Jim did not like it.
Jim did not. But most of my team retired from Intel in Hillsboro. But Dane's right. Jim Lally was picked to be the general manager of that single board computer group that went up, and it didn't set well with him. He lasted. I don't want to say he lasted, but I guess he kind of he put up with it for a couple of years, and then he came back, and I think he left to join Kleiner Perkins around that
That's
time.
right. Now, he and Lynn did not like Portland. I don't recall any details, but
Yeah.
he quit and came back, went
Yeah.
to work for Kleiner Perkins.
So I was back in development systems for a couple of years.
Okay. You made a couple of comments in here about the 1702 and the profitability of 1103s, 1702s, and whatnot.
Oh yeah.
Static RAM, because that was the primary business we were in.
Yeah, that's
It
when I
wasn't
joined in
It wasn't
72.
4004s.
That's right. No, they were good.
1702s got me started with Intel, because I had built a computer that used those for
Yeah.
main memory.
Yeah.
And I was paying $200 a copy for those little ones.
Wow. Wow.
So they were, and for years I think that was a loss leader or
Yeah.
not a loss leader, but a very profitable
Yeah.
product that they kept out of everybody else's hands.
Yeah.
You also mentioned Ted developing the bit slice machine, the
Oh yeah.
R4000.
Yeah. I think it was called the 3000.
Yeah,
back then, right?
R3000, I'm sorry.
R3000.
Wildfire was our code name for
Oh,
it.
okay. Okay.
And I was wondering if you had any other thoughts or comments about that and the viability, because AMD went on to build a bit slice that made a big business for them.
Well, the thing I remember two things. I remember Justin Ratner was assigned to do the marketing, I think, for Ted's bit slice machine. And the other thing I remember is that the code could not be compiled to completion. It was you couldn't write a compiler that was deterministic for that particular architecture
You mean to create the microcode?
to create the microcode. And so I think that was a big handicap that it never overcame, and I don't think it went very far.
To my knowledge, there were only two people who could actually build the microcode
Yeah.
for that. One was Ted himself,
Yeah.
and the other one was Klingman, who
Oh, okay.
did that
Okay.
for a long time. He wrote the coursework on
Yeah.
doing that.
Back to 72, I have a story about that's not in there. It's kind of fun about the technology back then. Dana's right. The 1103, that was a breadwinner. 1702, probably the most profitable of all.
Yeah, but not the volume of the 1103.
Yeah, but Intel had some had static RAMs, but back in 72 when I was hired, Bob Noyce would always. There was only 500 people, by the way, at Intel when I was hired. It's you too, and back then, Bob would hold a lunch, a monthly lunch for new hires, and I remember being all excited about going to that first lunch. And it must have been about 8 or 9 of us with Bob leading the way. And I listened with bated breath to every word he said. And one thing he said, I took away as like gospel. And what he said was, it's the static RAM. Watch the static RAM. That's going to make Intel. And I saw for a while, quite a while, I kept watching for the static RAM to take off. And they were good parts, but that was not the it turned out to be the microprocessor.
Well, we made a hell of a lot of money on 2102s.
Yeah, yes.
But that was mainly a Hank O'Hara deal because
Yeah.
we were the only guys that produced them, and Hank got $50 a part.
Oh, wow.
And and I've talked with Hank about this several times, although he's tending not to remember too well anymore. Nobody else could make them, but everybody, there were like 10 companies who claimed they made 2102s.
Yeah.
1K static RAMs.
Yeah.
And so we never had any backlog on the books
Oh, wow.
because everybody else claimed they could make them and they'd sell them to you for $20. And so every month the sales guys would come in and say, but I can't sell any of these things at $50. And Hank would say, too bad. Let me know at the end of the month how many you want. And he went and just built the hell out of this product. He said, the first time I lose a 50,000 piece order, I will drop the price.
Yeah, okay.
And that went on for 2 years.
Wow.
True to his word, somebody else came in and delivered a large volume.
Yeah.
And I think the price on them was $23 or something like that. Hank dropped the price to $9 the next day.
Wow.
And put everybody making static RAMs out of business because our cost was, we had just moved to plastic packaging for that.
Yeah.
And our cost was somewhere around 98 cents.
Wow.
So
Wow.
it was a hell of a deal.
So around this time, I guess you were approached by Hank Smith about the Apple.
Oh, yeah, that's a good one. Thank you, Uday. Yeah. So I was, I guess, about my 6th year at Intel, roughly, and I was really happy. It was a great company, and actually the best company I ever worked for. And so I get a call from Hank Smith. He had joined Venrock, venture capital company managing a lot of Venrock, Rockefeller money. And he told me that Mike Markkula had hooked up with a couple of guys in Cupertino, and they wanted to talk to me about some management job, And so at the time, and I said, well, what are they doing? And he said, well, they've figured out how to hook up a keyboard and a microprocessor to a television set, and create a I forgot what word he used, desktop computer for a very low cost. And the word PC wasn't invented then, and but I was very kind of got on my high horse a little bit because I'm at Intel, we're the king, and I happen to know, because I was at Intel, that there were about 19 or 20 of these types of startups out there, and in fact, Rich Boberg, the engineer I met, he had left in part to do one. He and his good friend had one of these things. He was using Intel. So I knew there was a lot of them out there, and so I put my Intel Proud hat on, and I said, well, what processor are they using, Hank? And he said, it's 6502. Oh, Apple, huh? Oh, no, wait, I didn't. I did. No, I didn't. I said, I thought, oh, Motorola, huh? Hank, I'm pretty content right here at Intel, and I declined to take the interview. And of course, it was,
Jobs.
Steve Jobs and Steve Wozniak that wanted to interview me, for God's sakes. So that was a couple of years before I left, but it had a lot to do with why I left.
So then then the opportunity came about Convergent.
Yeah. So I was back in development systems and just managing. I was a department manager, tell you the truth, I can't remember what I did in those last 2 years, but a couple of guys from DEC came in. One was Alan Michaels, one was Cal Hubler. Alan was a sales guy, both were sales guys from DEC. And Phil Kaufman, right? Phil Kaufman hired them. So I was on Phil's staff, and this was before Phil left to found Silicon Compilers. So I worked with Alan for a year as a peer, you know, and when Phil left, Alan got his job, and so I'm working for Alan. And unbeknownst to me, oh wait, let me back up a little bit. Alan comes up with this notion called the Universal Terminal Computer. And it's a system, and it's a general purpose system. So, and I'm not involved in it, I'm doing I'm managing engineering, hardware engineering for the development systems proper. Terry Opendijk happened to be my counterpart doing all the software. So Alan needed to present the system idea to the executive staff, just that I had to present the single board computer to the executive staff a couple of years before. So Alan, I think I was in the meeting just as a observer, because I was on his staff. He presented it, and it was rejected. The concept was too competitive with our, with the mini computer companies and computer companies that Intel served. So it got shot down. So unbeknownst to me, Alan pulls a team together. Not the one team. There was him, one of my engineering managers, Elliot, and Alan's secretary, Donna Haas. They were working secretly on this plan to do a startup, to do the UTC, the Universal Terminal Computer. And Ellie was a really smart guy, but he was his management style was horrendously bad. I think it's probably the biggest hiring mistake I made. I thought with my great management skills I could harness this really great talent and teach him how to manage, but he was within days I had young lady engineers in tears. And Ellie was just horrendous. But Ellie was the guy that was first to do engineering for Alan's startup. Something happened, I don't know, I don't have any idea what it was, but Ellie was out of the deal. And mind you, I know nothing about this. So one day Alan approaches me and tells me that he's going to leave the company to do a startup. And so the apple gun was sort of cocked in my head. I'd missed out on a big startup opportunity. That was the case, and so I was kind of primed to want to do something like this. And there was one other thing, as I mentioned in my notes. By then, I knew that Intel was first and foremost a silicon company. Whenever decisions were made, they were going to be made, and I would probably never be able to do general purpose computing inside of Intel. So I told Alan I got to think about it, but I didn't think too long. I told him, okay, I'll do it with you, and so I left and co-founded Convergent Technologies shortly thereafter.
It was located here.
And it was located here, yeah.
You got a date for that?
Yeah. Well, August 1979, I want to say August 1st, 1979, but I'm not, I should check.
I'm sure that's in the web someplace.
Probably, yeah. Yeah, yeah. So, you know, we had to wind down our responsibilities at Intel. I met with Roger Borovoy, and he asked me not to hire from Intel, and I promised him I wouldn't, and I never did. And we started, and it was only 3 of us at that point. It was me, Alan, and Cal. And we didn't even have an office, and we didn't even have a business plan, frankly, because Alan had garnered commitments from 3 notable angel investors at the time. Dick Reardon, who eventually became mayor of LA, John Friedrich, who is the founder of Ware Fletcher Friedrich firm, and Bill Rolnick, who was the founder and CEO of Rental Electronics. And I think this is one of those classic Silicon Valley stories where, and I wasn't a part of this, but Alan truly sketched out the deal on a napkin and got the handshake from those 3 guys for a $12.5 million Series A. And so they were the investors. And so that was pretty exciting for me. I had never leaped off the cliff like that before.
So this is for the first multi-purpose workstation for
Yes.
business application.
Yes, yeah. The basic concept was, with the power of the 8086, 16-bit computing, and the affordability that a system surrounding it could support, plus a real-time multitasking operating system that was yet to be invented, a workstation could be created that could support multiple business applications. And at the time, Wang sold a desktop system, but its sole purpose was word processing. And Ari Feingold and Dave Stam and with V.K. Kozlow notably had created Daisy Computer, which there was a single workstation could support schematic capture, but there weren't any systems out there that could handle multiple applications on the desktop for an affordable price. So the idea behind Convergent was to do that multi-purpose, multi-application desktop system.
But in a professional environment, not in a home computer.
Oh yeah, not in a home. No, definitely a professional environment. And on the East Coast, Apollo Computer had been created to do a desktop entity, but its goals were engineering, technical workstation. They became a competitor to Sun. Convergent was a little different. It was going after business applications. And so within a week or so, 2 Xerox PARC, people were hired, Ben Wigbright and Jay Spitzen, both brilliant software people, to join Convergent in order to get that software. The challenges at Convergent were very substantial in hardware because we had to build, a complete computer system hardware, desktop and turns out pedestal, because we couldn't get it all on the desktop back then because of the size of the disk drives. Do all of that on $12.5 million and build an operating system from scratch, plus build a word processor from scratch. Ben, was reported to me as VP of software, and it was his job to get that software done. And so it was pretty
So
pretty
did you
challenging.
have a pretty rapid hiring as well?
Pardon me?
To hire the staff?
Well, we didn't have a big staff. We didn't have that much money. We started out with we hired about 10 or 15 people at the most, and got started. And I remember sitting down with Ben after he came on board after the initial start, trying to figure out how long it will take us to get production, get prototypes done. And I think Alan wanted it done in 12 months, and to me it looked more like 18 months. And Ben said, I gotta have 12 systems, or I'll never get this software done. So I'm thinking I gotta somehow build 12 prototypes, not just one. And so I came down and committed to 18 months. I told Alan I can't do it in less than 18 months, and so he accepted that, and we got started on with an 18-month plan to finish the workstation, and and we only had about 10 or 15 guys in engineering total. Most of them were software engineers because that's where the 12, prototypes came from. And I came up with this notion of a plywood workstation. And this comes from my aerospace background. I was familiar and comfortable with wire wrap techniques. And so, and by the way, back then, we had to design our own CRT controller and CRT, analog system. You weren't buying them off the shelf anywhere. Andy had to do it on his Sun workstation, and I had to do it at Convergent, and Dave Stam had to do it over at Daisy, and because it was a world of terminals primarily. These were, so I remember I'm just thinking of the plywood workstation. So we in 18 months we had 12 of those done, and before 18 months we had them done because the software guys needed them earlier. So. But the first engineer I hired hardware engineer I hired into Convergent was a fellow by the name of Richard Lowenthal from Berkeley. He happened to be comfortable and familiar with wire wrap techniques, and he did a beautiful job. I mean, it was pretty hairy trying to get all that stuff done and working reliably, but we were kind of experienced at it, so it wasn't like a crazy risk that we took. Rich, by the way, ended up co-founding Stratacom and Coulomb, the battery charging company.
Right, that's where I got it. Okay.
So how long did it take to get the first prototype done?
Oh, I don't remember. I know we met our goal of 18 months, but I can't remember here's something that's kind of interesting, intervening thing. That first workstation was to be a single node, single workstation. Xerox PARC got wind of us and came to us and wanted us to create a clustered version of this thing. And Don Massaro was the head of the Office Products Division, and Alan signed him up. He agreed to pay us $300,000 if we would extend our 18-month program to include a clustered version of the workstation. And so checked with Ben, figured out, well, maybe we can do it, but we need more people. So with the extra money, I increased the size of the team to maybe 20. The numbers are rough. And so we not only completed the IWS, which was the single node workstation. Richard helped me extend it to a cluster of 16, I think. The pedestal that contain the 8-inch disk drives along was turned into what we called a shared resource for the desktop terminals. And so yeah, we literally completed 2 types of systems in the first
What was the
18 to 20
communications
months.
protocol between the 16 units?
Interesting you should ask.
Aye.
Rich came up with this. He used a gate he used a gate that had had a differential output, not a 1 and 0, and so he used it like basically like an amplifier. And well, I can't say that he did that, but he did use a gate as the basis for the network that stitched the desktop things together. And I can't remember
So was
exactly
there
what he did.
one wire from each desktop terminal into the management?
I think you're exactly right. It was daisy chain. Output from one would go into an input from another, and the output from that one would go to the next, and next, and next, and next, and supported ample bandwidth. I don't remember the numbers, but system worked fine. We got some very interesting customers eventually, because we got Burroughs, we got NCR, we got Savin, we got Thompson CSF, Honeywell was looking at us, and what had happened in the computer industry is the bunch group, many of them, the ones I'm talking about, they fell behind when it came to utilizing microprocessors to advance their terminals. They ignored the desktop too long, and so they didn't have a product. And others were coming after them. The IBM PC was not out yet, but I guess they knew that IBM was coming along, and so we came along with this beautiful design. I hired some great engineers from Hewlett-Packard for mechanical design. We had these beautiful injection molded parts. Trying to think of the design team that designed. We produced the first articulated display where the plastic enclosure wrapped the display very, very closely. It was I wish I could remember the design company that did
Frog
it.
Design?
No,
It was
Wasn't
Apple.
Frog.
No,
Yeah,
Frog.
Apple was
Before
Frog.
them. It was
Frog
before them.
preceded Apple. So.
Maybe I'll think of it. But we had a beautiful design. Ben did a great job with the software. CTOS was the
So you're saying it
was the
became
operating
pretty
system.
high profile. People were coming and talking to you about.
Yeah, and they became our customers.
But I think the other interesting thing is that this is in some sense a predecessor to the serial what's the name of the original serial communication stuff that we tied everything together through the vampire connectors on cables.
No.
But that was a park.
Oh, is there? This. Yeah, the Ben and Jay were from Xerox PARC. Right. We knew all about the Alto, and we were, they weren't commercializing that. They weren't.
No, they weren't.
So we knew about that design. The CRT, concepts were based on it. The mouse concept was based on it. So we borrowed all those designs and incorporated them in our design. So it was a pretty cool system, and it met a need. It was the right product at the right time, because these big computer companies had kind of fall behind.
They really fell behind.
So you had
yeah.
5 generations done.
We at Convergent, I'm very proud of the fact that we completed 5 generations of Workstation in 4 years, and with a team of about 35, 40 engineers. I've just told you about 2 of them. The next one was took advantage of 5.25-inch drives to eliminate the need for a pedestal. We were able to put a hard disk into the desktop design, which was, well, you have to see it. It's a novel design with the CRT beautifully articulated on the left and a kind of a work panel on the right. But the work panel was actually a housing for a bus that supported the computer cards and the storage drives, the 5.5-inch floppy and a 5.5-inch hard drive. So that was it was called the AWS, I remember. IWS, Integrated Workstation, was the first one. AWS was the 5.25-inch drive base system. Then we did a color. We did the first color, and I hired a fabulous engineer to bail me out, actually, on the CRT design. It's Mike Ramsey, who became CEO and founder of TiVo. My first analog engineer on the system wasn't making it, and Convergent wouldn't have made it if it weren't for Mike. Mike came from Hewlett Packard, and fixed that problem, and he went on to design the color display, which was the fourth system. And then he led the team that created this beautifully modular system called NGen, based on the 3.5-inch drive technologies. That was the fifth. That was just a gorgeous system.
You mentioned Vinod and Daisy down here.
Oh yeah,
and,
yeah.
The interactions that happened among.
Oh yeah, there's a couple of thanks for reminding me. So, I'm at Convergent. I became general manager of the Workstation Division at Convergent, and I was managing all these customers and their products and making sure that we were moving forward generation after generation. Dave Stam and Ari Feingold had started Daisy Computer, and I knew them from Intel. And VK Kozlow was at the company, but he wasn't a founder or anything. He was just there. And Ari and Dave would ask to visit with me from time to time. They wanted to learn how I was designing for manufacturing and how we were doing workstations, the desktop, because they were building Daisy Computer, and they're trying to figure out on their own how to make their product more manufacturable, et cetera. So that's just something that was going on at the time that involves some people that you may have heard of before. And then the other thing that was kind of ironic is that one of my engineers, Drew Hoffman, came to me and said, "Bob, you ought to go over to Stanford and take a look at this workstation that's being breadboarded over there." And I was, okay, let's do it. So we go over and we met in Forrest Baskett's office, although Forrest wasn't there, but Andy Bechtelsheim was. He was there. And so I walk in the room, and Andy's there, and we say hello, and on the desk is one of my little Intel SBC Lexan motherboard products. It was like a slice of the multibus mechanics, and so you could put in about four cards. Behind this thing was this gaggle of wires coming out from behind a CRT. The CRT was facing the other direction. These wires were coming out all over the place, and I recognized it right away as it's a CRT controller design, because that's what we did at Convergent. And of course, going up the wall and across the ceiling and down to the desk is this big yellow cable, which was of course Ethernet. And Andy's telling us about the system, and I'm listening with great intent, and it was he described. I said, what's the yellow? What are those yellow cables? And I said, that's the Sun University network. Actually, it was internet, but that was the first Sun breadboard, I believe, and it wasn't an Intel product. It was based on Motorola. But Andy had taken that interest in multibus because he wanted to use the multibus. He initially intended to use Intel as a processor, but somewhere along the line, he and Vinod, I think Vinod was with him then, decided, oh no, not yet. Andy was still showing people what could be done.
Yeah, I was going to ask you what was the reason for showing. Yes.
The reason for showing is that here's another workstation being developed, and we were a pretty high-profile workstation company, and Drew just thought, my engineer thought it would be, sensible for me to go visit with Andy.
So they were pretty open about it.
Yeah, very totally open about it. I think after viewing Andy's oral history, I can piece this together a little bit better. I think at the time they were looking for someone to fund them, or they were actually looking for people to sell that to, license the design to. So perhaps the invitation came for that reason, that Andy was Convergent was one of the few companies that Andy was looking to license the technology to. And after listening to his oral history, I realized that he eventually just decided we better just do it on our own, and he and VK and Scott left to do that. But that was just a coincidence, but it takes me back to, and little did I know that I'd be meeting Andy again just in a couple of years.
So you were at Convergent for a couple more years, and then...
Yeah.
So what made you think about looking at Sun?
Risk tech. Well, first of all, I tried to retire after Convergent, and as it still does, retirement doesn't agree with me very well. I don't care for it. I'd rather. One thing I've come to realize is that I enjoyed being an engineer in the beginning. I enjoy working with engineers. I enjoy working with the technical community. I have all my life. I still do, and it's been an enjoyable profession for me, put it that way. So I tried to retire, didn't work, and I was intrigued by RISC technology. I'd heard about it, read about it, and lo and behold, it was like the microprocessor. I sensed something afoot, right, that I should latch onto somehow, and I wasn't, and so I figured out that Sun was going to pursue it, or was pursuing it actually, and got interviewed by Bernie Lecroute. He was the executive VP under Scott for all the workstations and everything, and I eventually got hired. I joined Sun in December of 1985.
So you had not met Bernie before that?
No,
Okay.
no, I hadn't met Bernie. Oh, here's actually the connection. I was sought out. I just remembered that. A fellow by the name of Russ Bick, who was the first VP of manufacturing at Sun, worked at Intel in the development systems group, in the manufacturing group. he recommended to Bernie that he seek me out, and VK knew me from Daisy, so I guess I had two sponsors at Sun, Russ, who was just leaving, and VK, who it turns out was just leaving as well. You know that whole story where Sun, where Scott came in to run the company. So, yeah, that's how I ended up meeting with Bernie. I met with Scott, got interviewed by Scott, and they hired me. And so back in the workstation business again, and it was that was a lot of fun. Sun was just a lot of fun.
So you had an interesting very first day when you went to.
Oh yeah, the first day, yeah. Like the first day was one of Scott's staff meetings. So Bernie goes there, and all of Bernie's reports, which included me now, go to this big conference room, and I walk in, and Bill Joy's at one end of the room, yelling and arguing with somebody at the other end. I can't remember who it was. And they go on and on. They're back and forth, and people are chiming in. And Scott's just sitting there, kind of with a grin on his face, taking it all in. And I'm thinking, what the hell? This is wild. and I don't even, well, so Scott quieted that group down. I forgot the rest of the business. I was just wondering, what the hell were they arguing about, you know? And so I think it was actually the next day, Bill Joy comes into my new office, and he plunks down about a stack of Xerox copies of his emails, about 8 inches high, and slams them on my desk and says, "Read these." And you know, what am I going to do? You know, so I really didn't have the time to read them, but it was the first kind of a clue to one of my first big decisions at Sun was coming up. You know, I'm still just trying to get the lay of the land. You know, so this is within the first month to 6 weeks of Sun. So the next thing that happened, well, not the next thing, but so shortly thereafter, Scott comes into my office, and the picture starts to clear up, because he says, "Bob, we've had this project going on for 4.5 years. It's a gate array. It's our wrist chips, and I'm getting tired of it. You know, it's not going anywhere. 4.5 years. Bill Joy's behind it, and Fujitsu's the vendor, and I don't know what to do. So I want you to decide whether we finish this or shut it down." And so okay. One of my
It's
first.
called the Sunrise Project.
Yeah,
Yes, it
yeah.
was.
What was the name of the project?
Sunrise.
Sunrise.
That's
Okay,
right.
Sunrise, and it was a, so I started trying to figure out what the hell was going on, and I learned a couple of things. I learned that it was a gate array, big gate array, and that some section of the gate array design had to actually behave like an analog circuit, and that wasn't consistent with Fujitsu design rules. And so I think, oh, that's not good, you know. And but the other thing I learned is that the next tape out was in about 8 weeks. And from my experiences at Intel, I knew a little bit about the psychology of chip design, you know, and when they're making progress and each tape out yields more functionality, you know, the psychology's kind of positive. But when it stalls out and doesn't go anywhere, it gets negative pretty quick. And so I went back to Scott and I said, "Okay, Scott, here's what I've learned. Here's what I'm going to do." And I told him that the next tape out is in 8 weeks. I'll tell you what, if that silicon works, fine, we just keep going. But if it doesn't work, I'll shut the project down. And he said, "Great, fine, do it." And so I didn't know what was going to happen. I had no idea. I'd only been there about 6-7 weeks. And I just you know, and you know what happened. that was the first silicon that worked after, I guess, 4.5 years.
Right. Anant Agrawal was the manager.
Yeah, not Agrawal. Yeah, absolutely.
And I think part of the design problem was the fact that a quarter of that gate array had been cut out, and there was a static RAM, was it
Yes.
static?
Right.
RAM for the register array
Mm-hmm.
being put in there. That may have been part of the analog problem with sense amplifiers and whatnot to make that work.
Could have been.
We were amazed.
I figured that was that was probably the basis of the argument that I witnessed when I went in my first staff meeting at Sun.
I think the target was 15 megahertz or 18 megahertz, something like
Yeah.
that.
Yeah. So Sun was one of the other things that just blew me away at Sun was I had a very talented team at Convergent. I was Harvard professor, you know, I had these great analog designers, you know, et cetera, and you know, a couple other notable people from Convergent. I don't want to forget them. Is that Bobby Johnson? He was a software engineer, networking engineer, software engineer. Became the CEO and founder of Foundry Networks. Pretty big play. And one other notable CT engineer. Maybe I'll think about it later. But back to Sun. See, where was I?
So then after the gate array, Sun Ray was the project with Cypress.
Yeah,
So
yeah.
you
I had a couple of things that okay. So the a year later or so, I get involved in what I like to say is that my favorite project of all time, because it was in fact a full custom chip design. Code name was Sunray, and I got to co-lead that project with T.J. Rogers, one of my favorite personalities in the computer business, and the project was enormously successful. But to get it started, I had to somehow get T.J. and Scott McNeely to spend more than a few minutes in a room together without blowing up into an argument. They were two extremely bright, competitive guys, and my office was just a couple of doors down from Scott's, and occasionally I'd see TJ come by, and sure enough, it would be a little mini explosion, and they'd be walking out. So. And I kind of wanted to do this project. I thought it was pretty cool.
Who else was being considered besides Cypress as a source?
Yeah, I don't recall. TI might have been one. I don't know. But TJ apparently wanted to do it. Uday confirms that at the time. Changed his mind later, but
I think the broker was John Doerr. He
yeah,
was on the board of Sun
that
and
makes sense.
Cypress.
That makes sense. Yeah, that makes a lot of sense. So
I was in there on the other side.
Yeah.
Okay,
So
because I was sitting there saying, if we want to be in the microprocessor business, then we ought to go with MIPS.
Oh yes.
And my rationale for that was that Sun was a big, strong company, and that's great, and we sold them tons of static RAM.
Yeah.
Because that's how they did all their caching was with our static RAMs. But if we want to control the business, MIPS is a small company with as good an architecture.
Yeah.
But we could be much more in the driver's seat if we went with MIPS.
I see.
TJ's ultimate decision wasn't John Doerr, wasn't any of that. It was he couldn't afford not to go with a company he sold the most static RAM to in the entire world.
Well, so knowing what I had observed about TJ and Scott, I decided if I wanted to do this project, I was going to have to get them talking to each other, I reckon that TJ was the more mature of the two. I think they were about the same age, but so I invited TJ to come up to my house one time and just to have a heart-to-heart talk, And I convinced him that if he wanted to do this, he had to somehow, be able to work with Scott, and they had to be able to stay in a room together long enough to continue to work. So he left, and he must have taken it to heart, because he and Scott came together, and we put a 30-man team. TJ and I put a 30-man team together. 15 from Cyprus. Uday was from Cyprus. 15 from my side, and we started that project.
There was not a manager from Sun's side. I was running the whole thing for some time.
Oh, okay.
And that caused some issues, when we first got started with Wayne Rosing, bringing John Pendleton, asking us to do the design using the Berkeley tools.
Yeah.
And I think you came in to solve some of the problems at that time too.
Yeah, I remember. I remember hiring Jim Slager from Intel. He's a 286 designer, and he to lead my side of that project, and it was kind of a coming full circle. I'd worked for Intel for 7 years. I'd never done a full custom chip of any kind, so here I was a part of a big project to do a full custom RISC processor, which was great. And for some reason, TJ and I set the same goal, about 18 months to get to first silicon, and he was just a masterful leader. We would run these weekly project meetings, like 2 project leaders, but it was him. It was his show, and he would drill down on guys like Uday with all kinds of minutiae that they make him feel.
He was very much involved with details.
He was amazing. It's just amazing. But
what's interesting was that we had heard that there was talk of bringing the teams together by offering stock options of the other company to the other team. I don't remember if that.
I know that must have been between him and Scott.
Okay.
Yeah. I had only seen this once before in my career, and what I'm talking about is 100% functionality on first silicon, and it was Matsutoshi Shima in his 8080 while I was at Intel. He accomplished that, and it was amazing. And TJ and the team did actually accomplish that in 18 months. The first silicon was...
Right. Not only that, but the target was 33 megahertz.
Yeah.
And when it was announced, it worked up to 50 megahertz.
Yeah. Before the project finished, Sun had to reorganize all its VPs. We had something like 50 VPs. and Bernie asked me to run worldwide manufacturing, which was an amazing assignment, one of the most interesting assignments in my whole career. So I don't think I was still in the Workstation Division when Sunray was completed, but I certainly got it started. That was pretty cool.
So there was an interesting note that you mentioned that in one of the staff meetings, Bernie's staff meetings, you discovered that the products were not FCC compliant.
Oh yeah, that was, the first 6 weeks kind of was that first staff meeting, and then the Spark, and it wasn't called Spark then, but then the Fujitsu problem. Within probably a week of that or so, I'm at a staff meeting, one of Bernie's staff meetings, and I'm listening to the conversation, and I realize that the entire Sun product line is completely non-compliant with FCC EMI regulations. And it's a pretty serious problem, because if you remember, maybe it's still that way, but FCC was self-certified. back then, in those days, your system. And at Convergent, we did all that work. We did all that, made sure we were completely compliant with all the basic safety and EMI standards. And I discovered the Sun was completely untested. And problem with that is that if a competitor had gotten wind of that, he could have gone to the FCC and created all kinds of hell for Sun.
Literally shut you down.
Could have shut us down. And I had a veteran engineer by the name of John Garman from Hewlett-Packard, who was a compliance engineer, but a really solid, well-versed engineer in many disciplines, running engineering services for Sun. So the technical answer to the problem was something called spring fingers, which we used at Convergent on that very first system, the IWS, because it had a pedestal. And spring fingers are these long pieces of stainless steel that are shaped so that they have a springiness to them. You bolt them, you rivet them to the side of your front panels in the chassis, and when the two mate, you get a complete electronic seal, and everything's fine. But getting those spring fingers into the Sun product line, which by then, even then, was a very complicated line, took about $15 million in 18 months. We were exposed for about 18 months. But John got it all done, and we got all the testing done, and dodged a giant bullet. But that was surprise number 2 at Sun. Probably were many surprises.
So a lot of
now
the
that I think about it.
manufacturing was moved to Milpitas then?
Oh yeah. Manufacturing was done in Milpitas at the time. Actually, the original Sun headquarters is very close. So right over here, just a few blocks from the Google headquarters, and our manufacturing was over there too. And so we kept growing and growing. Sun was at the time judged to be the fastest growing computer company in history, and Scott drove that. He believed in driving revenue, kind of in an unqualified way until the company hit the wall. And the company had such great talent and hardworking people. It just kept meeting its quarterly goals, quarter after quarter after quarter. And it was a combination of, as it was then always, is engineering, handing off product to manufacturing being able to get it smoothly into production. It was anything but smooth at Sun, though. It was like all companies, But I had learned some lessons at Intel and at Convergent, and the manufacturing team over here. We set up manufacturing in Milpitas, and funny story associated with that. Coincidentally, Joe Roebuck, who headed all U.S. North American sales, moved the sales force from Mountain View to Milpitas, but he didn't refer to it as Milpitas. He referred to it as Milpitas. And I think the sole reason Joe did that is because he lives in Lafayette. Or he lived in Lafayette back then. It simply reduced his commute. Which reminds me of something I didn't mention earlier. I'll just throw it in real quick. Back when do you remember Adam Osborne?
I do.
Osborne Computers? First time I met him was back at El Dorado, back up in Concord. He was a technical writer living in the East Bay, and he came, and we brought him in because we needed a manual, a user's guide for that quote intelligent terminal that I told you about. But Joe was his first VP of sales at Osborne Computer. So Joe was with either DataPoint or DEC. Not sure which.
No, I think it was with DataPoint.
DataPoint, I think. He came out west to join Osborne Computer, and that cratered almost immediately because of product problems, not because of Joe.
Did you meet Adam back at Intel?
No, I didn't. I
Because-
met him.
Adam had written a book called The Value of Power,
Yeah, probably
and then
did.
he wrote a second one called The Value of Micro
Yeah,
Power, or yeah, I think that was it.
I probably did meet him.
And we hired him to write the first 8080 user's manual.
Yeah.
And when we got this manual, of course it was Federico that had contracted him
Yeah,
to do
yeah.
that. And it was one of the worst things we had ever read. I mean, he took terminology like DPG and gave it a completely different
Oh.
name. Okay, it was just terrible. So we had a product ready to go. We had Adam had written this user's guide.
Yeah.
And we didn't have any documentation for the product because that was supposed to be the documentation.
Not good.
I think McKinsey and I sat down, and in 4 weeks we wrote the entire set of documents.
Oh,
for
yeah,
that
yeah.
thing. But Adam was just incensed that we didn't like that.
You know, there was another neat guy back then. I won't get into it because probably going too long anyway, but I just want to mention Gary Kildall. Cool guy, very cool guy. And I had some great times and interactions with him back when I was at Intel, but I'll just...
Well, his compiler, his PLM compiler
PLM.
for us, made the
Yeah,
day.
yeah,
Just
yeah.
phenomenal effort.
He was just another of my favorite personalities in the computer business. So back to Sun. Where was I at Sun?
Yes, so basically we were trying to use a manufacturing in
Oh yeah.
Milpitas, and then I think you also initiated outsourcing.
Yeah. Well, let me tell that story. But it wasn't me initiating it. I kind of regret doing that. But this is 87, 88 maybe. By then we were manufacturing at Sun was very vertically integrated. We had 600,000 square feet of floor space over in Milpitas, and about 2,500 people. There were another 500 people in manufacturing spread around the world, but about 2,500 jobs, if you will, over there in Milpitas. And we had, when I say vertically integrated, we had surface mount board lines for all the desktops. We had material highways going all over the place for the desk sides, which were typically built to order. And we had there were so many software releases per month. I think it was like 25,000 releases a month out of Sun. We had a manufacturing line set aside just to crank out whatever the media was, CDs at the time, whatever. But what a complex product line. It was too complex. And so I moved over to Milpitas, and I'm running the worldwide manufacturing from that location. And we ended up in a pickle, a real pickle, in the third quarter of 1989. The company used an ERP system called Culinet. No, I'm sorry. It didn't have an ERP system. It had a bunch of spreadsheet. Manufacturing used this MRP system called Man from Ask Systems or whatever. But if you knew about Ask and Man back then, you would say, how the hell could you be running, a $1.9 billion operation on Man? Well, it wasn't just Man. It was Man and about 1,000 spreadsheets that all the manufacturing guys maintained, but it all worked. It all worked because the team was experienced and hardworking and kept at it all the time. But this pickle we ended up with is we had to cut in this new ERP system to Sun called Culinet. And, for these things, you need to train all the various organizations. You take, years to get them ready to make this cut over. And things kept, we weren't ready, so we kept delaying that. But coincidentally, we needed to introduce 5 new hardware products into the manufacturing process that same quarter. Same kind of thing. They weren't intended to be introduced all at once. They were scheduled out over some reasonable sequence, but things ended up having them all come together at the same time. Plus, we redesigned 3 processes within the manufacturing line. So all these changes had to take place in 1 quarter. And up to this point, Scott had driven the company perfectly successfully, quarter after quarter, most aggressive possible revenue objectives every quarter, and he met them time after quarter after quarter. This time, we had bit off more than we could chew. And it turned a simple thing called a material transfer form shut the whole company down, the whole manufacturing process down, because Culinet demanded stricter authorization compliance to transfer material from one building to the next. And the team, no matter how much they trained, they weren't ready for it. And we couldn't move material from one building to another that quarter for 5 weeks. For 5 weeks. And I didn't know what the hell was going to happen. And so things got real basic that quarter. And I started tracking. I had my staff report to me every day how many systems shipped. And shipment back then, the rule was you move the fully packaged system across this big yellow line at the back of the manufacturing buildings, and you were officially shipped. And that's just the policy then. And I got nothing for 5 weeks, And what I was doing, we needed to ship about 35,000 systems total that quarter. And what I was doing is calculating the run rate that we'd have to achieve once we got going. And of course, it was going up and up and up and up because we weren't shipping anything. Finally, after 5 weeks, they solved the problem. Material began to move, and it was. Oh, I forgot to mention what happened before that. About 9-10 months before that, the CFO of the company bailed out. He quit. I don't know if it's the reason, but Bernie left. My boss left. And then my VP of manufacturing, he left. And I think there was one other senior exec left. So everyone was bailing out. Oh my God, we're going to hit the wall. And I decided that I was going to stay. I didn't want to leave Scott in the lurch. I wanted to stay and hang in there. Didn't know what the hell was going to happen. But the team was just amazing. They kept working at it. The shipments started up, and my calculated run rate, started to drop. And I'll be damned if we didn't ship all 35,000 systems that quarter. But we didn't make our revenue because all the stuff that was to get to Japan didn't go through customs, so we couldn't count those, and we had to report a first loss in I don't know how many quarters. So that was the quarter that Scott finally hit the wall, and it was quite a quarter. But the other thing that I mentioned in thinking about this that happened during that period, I stayed for another quarter, and then I tried retirement again. Actually, I did another startup, but not an important startup. But think about all those jobs that we had over there and all that manufacturing capability that we had know-how for. That was 1989, not too long ago, and an engineer, not a manufacturing engineer by the name of Jim Otts, came to me, and Jim, you remember him from Intel?
I do not.
Yeah, he was at Intel. Maybe it was at Convergent. But he came to me one day with a request. He wanted to, he said, I found a contract manufacturer, and I can't remember whether it was Taiwan or China. He says, these guys can manufacture this motherboard, and it was a motherboard for one of the desktop systems, cheaper than we can, and they can do it in volume, blah, blah, blah. Do you mind if I just try it as an experiment? And I thought about it, and I said, well, it's just an experiment, How much is it going to cost? We talked about it. It wasn't going to jeopardize any of Sun's manufacturing ability. But I said, okay, good, give it a try. But within 10 years of that, that entire complex in Milpitas was gone. That was, and I didn't understand the significance at the time. That was the start of the big outsourcing. That was the time of the big outsourcing moves that manufacturers made back then. And at least that decision was not political or anything of that nature. It was just cost cutting by an enterprising manufacturing
There's still
production
one
manager.
building where you can see the faded sign, Sun, still.
Yeah,
There's
you
one
can. Yes,
on
you can.
237.
Yeah, the faded sign. Yeah, those are the buildings I ran. So that was kind of an interesting
So then
time.
as you said, you retired, you tried to retire, and then
Yes.
again you started, co-founded Liquid.
Yes,
Computing.
I was. Oh, by the way, it was Bernie Lecroute in my interview that told me that what I'd been doing in my career was following discontinuities in technologies. Because the microprocessor and then RISC, and I was lured into my last major startup by the same phenomenon, and it was a company that ended up being based in Ottawa, Ontario, Canada, and it was I was a founder, but I was the only U.S. person. The rest of the founders and the board, save a friend of mine from Intel, were from Nortel. And the architecture was really exciting. It was basically you take the conventional network between nodes of a mainframe computer, and you replace them with a switching fabric, not just any switching fabric, a fat tree point-to-point, super high bandwidth, switching fabric between all the nodes. Really a phenomenal architecture, and I know that because I ended up converting myself into a business development guy then, because what the hell was I going to do here in California? Ottawa's more than 3,000 miles away. So I ended up being responsible for the national labs in North America and all the high-performance computing labs in Canada, various universities, and some of the national labs in Europe. So I was selling to some of the biggest, and best HPC customers in the world. And, Liquid was highly regarded by most of them. Mark Seeger, Lawrence Livermore. I had an evaluation system, NASA Ames, right next door to you guys. Took a system in Lawrence Berkeley National Labs. Same thing in many other labs around the country. And where Liquid had a very enticing concept, but there was a fatal flaw, and it kills me to this day because I picked the right architecture, but I ended up as you said earlier, snatching defeat out of the jaws of victory in the end, because the fundamental problem was the thing cost way too much for the computer industry to accept, even the HPC community. It was about twice the cost, and I proved that on 2 occasions. Once at Lawrence Livermore Labs, twice at Lawrence Livermore Labs, and the guys in Ottawa just wouldn't accept it. But the reason it was designed to be NEBS compliant, because for the guys in Ottawa, the backup strategy to the whole thing was to sell it to Nortel if they couldn't sell it elsewhere. Of course, Nortel went off a cliff and ultimately went under. So that strategy was not a good one. But talk about beautiful hardware. My God, it was a quad Opteron big motherboard, liquid cooled on board. Beautiful hardware on it, great big system. The problem was Mario Mazzola over at Cisco got the same idea a couple of years after we started. We started in 2003. And he spun out a small group, to do silicon for the switching fabric. And being good system builders, system architects, they crafted a working system, and they were very, very shrewd because they made it modular so that they could offer entry-level versions, starting points. And for instance, the liquid system had these gorgeous, giant, 14-inch by 15-inch liquid-cooled boards, and it also had a backplane, which was the heart of the switching fabric, which had 56 layers. 56 layers and over 3 miles of wiring inside of it. Super high bandwidth. And the software was good, the system worked. It was just way too expensive. The entry-level price for a liquid system was about $900,000. The entry-level module that Cisco sells, well, it used to be about $42,000. Cisco sells tens of billions of dollars of those every quarter. It turned out to be the UCS, Cisco's UCS, the Unified Computing System. And the project that Mazzola started up was called the California Project, I believe. And he spun it out as a startup, and when they proved that they had when they got the chips working, Cisco bought the company back, and the engineers came back. A very smart strategy.
They've done it many times.
Yeah, I made a serious effort with Liquid. I was there a little over 6 years. We went through about $88 billion at least, and I sold the first system, but it was for naught because it was too expensive.
Wow.
And the Ottawa founders and board, they wouldn't accept it. They just got.
So then that came to an end, and so now you're.
Oh yeah, that was when I said to myself, no more all eggs in one basket. And ever since I've been consulting, and I'm very happy to be doing that, because that kind of hurt. That was a serious effort, and it should have succeeded.
Those basic flaws.
That was a big one. And it really was frustrating because at Lawrence Livermore, I demonstrated very obviously within 6-7 months of having the system under evaluation that cost problem was there. And they just wouldn't accept it.
Anything notable now that you're working on?
No, I'm just
Just
grandkids.
Okay.
Grandkids, my sons. I have one son, I'm proud to say, is a veteran software engineer doing great work. My other son is truly a world-class athlete doing good work in his field, which is tennis. And 2 adult granddaughters, very proud of them, and 2 teenage grandsons doing great things at the high school level now. So, and my wife Roberta, who keeps me keeps me on the straight and narrow.
So, any advice for the people that are starting their careers right now?
Yeah, I guess if you can, find a profession that you love. Find work that you love, and then the other thing is, if that's working for you, be bold when it comes to looking for the next challenge. Don't be afraid to go into an area that's beyond your past experience or might push the envelope for you. Just those 2 things, I think, help people stand out and get ahead and enjoy their chosen profession, whatever it is. So,
Bob, thank you very much for your time.
Thank you, Bob.
well, thank you for inviting me to do the oral history. It's a pleasure working with you guys and remembering and recalling all of those old connections that we both know so well, but can't quite dredge up that easily anymore. This is fun.
Thank you.